conotruncal region has now moved from the left to the right. So in an individual who has this abnormal looping, you are going to locate most of the structures that are supposed to be on the left, rather on the right side. Okay, so like this one, are going to have this aorta more to the right, okay, than the normal position. So that is what the dextrocardia and therefore the clockwise looping brings about. However, individuals that have this situation will live normally. Okay, so let's note that. So remember that we had a cardiogenic mesoderm or region within the splanchnic mesoderm. Then we realize that the angioblastic cords are going to come together to form the endocardial heart tube, as you can see, through lateral body folding. Once that is achieved, you have the primitive ventricle, you have the bulbus cordis there, and then primitive atrium, which will undergo a normal looping anticlockwise to form this, and then eventually you have that. We also talked about the aortic arches and their derivatives. So in effect, and in summary, this is what we are talking about. Cardiogenic area, you have primitive blood vessels there formed through vasculogenesis and then sometimes angiogenesis. So these are the heart tubes that are coming together. They are fusing here to form a primitive heart tube. Then they form this, they canalize and then form one complete tube. From superior to inferior, you have truncus arteriosus, bulbus cordis, primitive ventricle, and then primitive atrium. Then you have the truncus arteriosus and the rest of the structures undergoing the normal anticlockwise looping to position them at the place where it will actually assume its final position. So you have the ventricle there. You can see that. Then you have the left and right atrium moving superiorly. Hitherto, they used to be inferior. Neural crest cells, the ubiquitous cells that are found almost everywhere, they contribute to the formation of endocardial cushions as well as the septation of the truncus arteriosus, and for that matter, the formation of the aorticopulmonary outflow. So you come across them a lot. Endocardial cushions help in the septation or division of many parts of the primitive heart, including the truncus arteriosus and even the primitive atrium, as well as the ventricles. So let's see how the conotruncal region is septated or divided. Remember, the heart tube joined, they canalize and form just a single tube. However, that single tube has to be divided or partitioned. So this region where you have the truncus arteriosus is supposed to be divided into two to form the aorta and then a pulmonary trunk. How is that going to be possible? It's going to be possible by the presence of these endocardial cushions from the neural crest cells. So at this level 1, you have truncal region, ridges, because it's coming from the truncal region. So truncus arteriosus, you have left and right appositional development. Okay, so they are growing towards each other so that they meet. Then at level 2, you have this also appositional growth towards each other, but from 12 o'clock to 6 o'clock, unlike this one that was 9 and 3 o'clock, which will also meet. Then you come back again, you have another 9 and 3 o'clock around this bulbar region where you have bulbar ridges. So the bulbus cordis region. Again, you have that. So once that is achieved, you have what we call the aorticopulmonary septum created. So the septum has divided the aorticopulmonary region or the conotruncal region into two. One will be the aorta, one will be the pulmonary trunk. So that is how the septation occurs. This is so simplified. It is not straightforward like that. So let's use this diagram also. I got from the Developing Human Kit more. So just like what we saw earlier on, region 1 will have these truncal ridges. Then region 2 and 3 has bulbar ridges. Then you can see that now the aorticopulmonary septum is complete. So you have PT standing for pulmonary trunk and the A for aorta. Okay, so that is the position of the pulmonary trunk and the aorta at the level of 1. Then at the level of region 2, the aorta is going to be on the left and pulmonary trunk will be on the right. In region 1, the pulmonary trunk was superior, aorta is inferior. In region 2, aorta is on the left, pulmonary trunk on the right. In region 3, aorta is at the top, pulmonary trunk is below. So that is how complex this division can be. Okay, it is winding. So eventually, this is how it's going to look like. See, so that's the aorticopulmonary septum winding. Okay, and then the blue and red is representing blood flow between the pulmonary trunk and then aorta respectively. So you see, it's so complex. You are septating or dividing one tube into two, and yet it is winding. And different blood type also have to move through in terms of whether it is well oxygenated or less oxygenated. They don't have to mix. So that tells you that if anything goes wrong with this kind of septation or division, there's going to be a very big problem. So if all things go equal, you're going to have the pulmonary trunk and then the aorta, sending portion of the aorta.